All right, hello, Redbirds. Today we're going to talk about using gel electrophoresis. Gonna get this stuff out of the way here. um, and so we're going to start on slide 18. So it says using restriction enzymes for human benefit. So you'll see that vocab words, whatever. Restriction enzymes, when we talk about biotechnology, they play a huge role in biotechnology because remember what restriction enzymes do? They're like the scissors, the molecular scissors that cuts DNA. And so we use them to make your DNA fingerprint. Is a DNA fingerprint the same as the fingerprints on your fingers? No. The fingerprints on your fingers are your fingerprints. Your DNA fingerprint is what we use certain restriction enzymes to cut DNA in certain places, and then we put it into this gel and put some electricity on it, and then these bands move. So your DNA fingerprint is literally your DNA that is cut up from using these particular restriction enzymes. So it's not the same as your fingerprints. They're like two different things, but they're similar in that they are both unique to each person alive. Okay, nobody else has your same fingerprint pattern. Nobody else will have your DNA fingerprint pattern. Okay, unless if you're a identical twin. Anyway, but they still could have slightly different fingerprint patterns. I think. I don't know. Anyway, so DNA fingerprint, it's a DNA testing. You might have heard of or seen this, like if you are big into watching like those CSI shows or like any crime scene, cop show, whatever, about DNA testing. Basically, they find DNA at a crime scene, they're going to create a DNA fingerprint from it. And then from there, like if they're suspects, they can get the suspect's DNA, compare the DNA fingerprint of what was found at the crime scene with that of the suspect to then connect the two. Now, just because like the DNA testing, the fingerprint, they match, does that mean somebody's automatically guilty? No, because there's going to be a lot of other pieces of evidence involved. This would be just one piece of evidence that detectives could use to prove somebody's guilt or prove somebody's innocence. So watch this video about real CSI and using DNA fingerprinting. Can you tell how related two samples are? Okay, so watch that video. So DNA fingerprinting, we use this process called gel electrophoresis. So since, like I said, everybody's DNA sequence is different, um, where these restriction enzymes cut and how big these bands are or the fragments of DNA are is going to be different. And since we have different DNA, if we cut it with the same restriction enzyme, our resulting segments will be different lengths. That's what it says. So when you look at the word, this thing, gel electrophoresis, gel literally is going to refer to a gel. It's kind of like a jello. It's not jello. It's a agarose gel that is used. It's a little bit firmer than like what jello is, but it's a gel. And then electrophoresis. I'm sure if you look at that word, and if we were all together in the classroom, I would say, okay, what does this word remind you of? Or what do you see in it? Yep, you see electricity. So they take electricity and apply it to this gel that has DNA in it. Okay, so what we do then for the gel electrophoresis to get it set up is you collect that DNA, and then they will put the restriction enzymes in it. So, like these little test tube looking things right here, that is like somebody's whatever DNA, and then they put restriction enzymes in it, the same restriction enzymes in each of them, so then it will cut them all at the same spot. The cut segments will vary in length. The segments are run through a gel to separate them. Shorter segments travel farther through the gel, so travel faster, and then longer segments travel shorter distances in the gel. So what happens then is they put the restriction enzymes in there, let the restriction enzyme do the work, and then there's like these little wells in the gel, and they will pipette those or that DNA and restriction enzymes, they'll basically put it in the well, and then they will um, they will put the electricity through it, and then electricity, as it goes through it, it will pull the DNA bands, it'll pull it through the gel. And then once it's done, it's traveled as far as it's going to go. Okay, that's great. Then it has like the banding pattern. Um, right here, the longer segments mean that they're like bigger, heavier, and then the shorter ones are like lighter, not as heavy. So you can see the shorter, not as heavy ones, they move farther because it doesn't take as much like energy to move them compared to the bigger, larger ones. I think it's going to say what I wanted to say. So, point number 6, but I'm going to go back to this slide right here. We have found that DNA has a negative charge. How do we know that? Well, when they decided to put electricity through it, they tried it to where like the negative end was over here to see if DNA would move. It didn't move. And then they tried to, oh, well, let's see, let's switch it around, put the positive end on this side. Will the DNA move towards the positive end? Yeah. Opposites attract. DNA is negatively charged. It is attracted to the positive end of the power source of the electricity. The front end of the gel is given a negative charge. It pushes it away, attracted to the positive charge of the electricity. The DNA bands now can be compared. Same DNA equals the same length of the segment. Stupid thing. I wish it would get out of the way. Go away. It's the same bands in the gel. Watch our little Amoeba Sisters video. I know y'all love that. And then you can see the different banding patterns that happen. A lot of times they'll use, they put a dye in it so you can usually see the DNA patterns. And a lot of times they'll put like a UV or some sort of dye that when you put it under UV light, then you can see it. Each fragment has a different length and charge. Shorter fragments, as we said before, will move farther. More negatively charged fragments will move farther, closer to the positive end. So then you could see here, like if this was the sample that was found at the crime scene, then they're going to compare all of this evidence that they've collected to see if anything matches to what is found at the crime scene. And we are going to stop there for now. So now I have a formative for you to go take. So please go and take that. And yeah, we'll see you tomorrow. Hope you go out and enjoy this beautiful weather. Peace.